Yeah, can all of you see this? Solubility?
Yes, sir.
Yes.
Okay. हमजा ज़ैद नहीं थे क्या टेस्ट में?
जी वो थे।
थे? अभी नहीं
हाँ।
है, कहाँ चले गए? उनको लगा छुट्टी। एक
ए,
सेकंड रुक जाइए।
पता नहीं।
चलिए ज़ैद ज्वाइन कर लेंगे। Solubility, okay? Solubility. So what is solubility? For that, I want to ask all of you one question, okay? If I give you, let us say, if I give you salt and I also give you sugar, okay? And you have 100 ml of water for both of them. So what do you think? Which can be dissolved in more amount, salt or sugar? In 100 ml of water, which can be easily dissolved in water? Tell me. Salt or sugar? हनीफा बताइए आप, क्या लगता है आपको?
Yes, sir.
Which will be dissolved in more quantity? Can we dissolve more amount of salt in 100 ml of water or sugar in 100 ml of water? Which will be easily dissolved, salt or sugar?
Salt.
Salt, right? Everyone agrees with this, yes or no?
Yes, sir.
Right. So salt is more soluble in water than sugar. Now, this is known as solubility. This is known as solubility. That means the amount of substance, amount of solute or substance that can be dissolved in a fixed amount of solvent, right? So in this case, we will say that salt is more soluble. Sorry, salt is more soluble than sugar. Salt is more soluble than sugar. And now after that, we will be also learning about what are the different criteria for solubility and what are the different factors that affect the solubility. One thing is for sure that the nature of solute, the nature of solute, what solute you are taking, that is going to define solubility for the, like, that is the main criteria. What are you taking, salt or sugar? Okay, like not only salt or sugar, या फिर कौन सा solute आप ले रहे हो, what other solute are you going to take? Okay, so right, first of all, solubility. What is solubility? Okay, first of all, we'll see what is solubility. So what will be solubility? Solubility will be the maximum. Solubility is, please write, solubility of a substance is its maximum amount that can be dissolved in a fixed amount of solvent at a given temperature. Okay, at a given temperature. Now, whenever we are going to dissolve something, please listen very carefully. So let us suppose that I have a beaker of water like this. Okay, I have a beaker of water like this, and is this part, and I have some water here. in this water I have added some amount of sugar, some amount of, let us say, salt. Okay, although it will not be, it cannot be seen like this, but I'm just representing it in yellow color that this is my salt. So you have NaCl. Now this NaCl is what? It is separated from the solution, and as soon as I add the NaCl inside water, I will get Na plus. This will dissociate into Na plus, which will be in aqueous state, and Cl negative, that will also be in aqueous state. Okay, that means both Na positive and Cl negative, they will be surrounded by water molecules. They will be surrounded by water molecules. So when NaCl get in contact with water, it gives you Na plus and Cl negative. But one more thing can happen. If Na plus and Cl negative, they come into and they bump together. So they come together like this. So what is going to happen? Na plus and Cl negative, they will attract each other and they can form NaCl. Okay. So the first process, it is known as dissolution. Where NaCl, it is getting in contact with H2O, is known as dissolution. The second process in which Na plus and Cl negative, they are colliding with each other and forming NaCl. Now this NaCl, it may be in the solution, but it is not dissolved in the solution. ठीक है, वो बाहर से बिल्कुल पता चलेगा. Will have NaCl. This is known as crystallization. So when the amount of NaCl is very low, that means it is dilute. Then the probability of bumping together is very low. है ना? The probability of Na plus and Cl negative colliding with each other is very low. But as soon as we keep adding NaCl, 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 है ना? If I keep adding NaCl, then what is going to happen? We'll see after a time there will be amount of NaCl that is present and that is not getting dissolved at all, right? So ऐसे थोड़ा सा यहाँ पे नीचे कुछ आपका जम जाएगा. So that is the NaCl that is getting separated from the solution by the collision of Na plus and Cl negative inside the solution. So is this two process clear about dissolution and crystallization? Yes or no? Please tell me.
Yes, sir.
Okay. So what happens in dissolution? In dissolution, when, what am I adding? I am adding, what am I adding here? Solute, no? I'm adding solute. When solute is added into solvent, I can say some of it gets dissolved, and its concentration in solution increases. Right? Its concentration in the solution, it increases. Is that right? Yes or no? Please tell me. Clear, right? Yes or no?
Yes, sir.
Okay. Next is crystallization. When solute particles collide with each other, solute particles collide with each other in solution, and what happens? And they get separated and get separated. Right? So this process is known as crystallization. Okay, this process is known as crystallization. Okay, this is crystallization and this is dissolution. Now, one more thing is clear. One more thing you should be remembering, that this equilibrium that is present between dissolution and crystallization is dynamic in nature. Okay, so the equilibrium between dissolution and crystallization is dynamic in nature. Okay, it is dynamic in nature. Chaliye, please write these 3 points. Dissolution, crystallization. जैद आप यहां से लिखिएगा सॉल्युबिलिटी से, सॉल्युबिलिटी के लिए आप स्पेस छोड़ दीजिए, ठीक है जैद? क्या हो गया था, आप चले गए थे क्या?
Yeah, I know.
अच्छा, हाउ वाज द टेस्ट?
Alhamdulillah.
Good. Other sorry for surprising you guys, huh? Next time say you will have on Sunday only.
Yes.
Okay. So please write this down, है ना? Hanifa, Alina, and Dania, also Hamza and Zaid. Raise your hand when you are done. Okay? Write it fast. Raise your hand when you're done. Okay, Alina is done. Waiting for others. Waiting for Hamza and Zaid. Waiting for Hamza and Zaid. Okay, Zaid is done. Just waiting for Hamza now. Hamza, are you done?
Yes, sir.
अच्छा, हाँ तो हाथ रेस कर दीजिए ना. अभी हुआ क्या? अभी हुआ होगा आपको बस. Okay. Now, next thing is there are 2 more definitions that you have to learn, and I think you already know these 2 definitions. That is saturated solution and unsaturated solution. Saturated solution. So a solution in which all of you know now what is saturated solution? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
है ना? So
Yes, sir.
saturated solution, a solution in which you cannot. अच्छा, I'm saying 2 things, है ना? A solution in which you cannot add any more solute or dissolve any more solute.
Dissolve.
Dissolve any more solute. ठीक है ना? Add तो कर सकते हैं, वो dissolve होगा नहीं होगा, that is dependent on whether it is saturated या unsaturated. Okay. A solution in which no more solute can be dissolved. Okay, it is known as saturated solution. It is known as. Also, one more thing is important, that at a given temperature and pressure, at a given temperature and pressure, because if I change the temperature and if I heat water, then more sugar can be added and it can get dissolved. Similarly, you will have another term that is unsaturated. So it is a solution in which more solute can be dissolved. Okay, more solute can be dissolved. Now, we have learned about what is solubility, what is dissolution, what is crystallization. Now let's talk about specific binary solutions. That means I will give you the phase or the state of solute and the state of the solvent. So first of all, we will discuss the solubility. We will discuss the solubility of solutions in which we have solute as solid and the solvent is liquid. So the first statement that I will be writing here is factors affecting factors affecting solubility of solids in liquid. Okay, so the first criteria of the factor affecting solubility is the nature of solute, right? So nature of solute and the nature of solvent. What type of solute and solvent we are using, that is going to affect the solubility. So the first point is nature of solute and solvent. ठीक है? So for example, solute में हम क्या use कर रहे हैं? Are we using salt or sugar? ना, if I keep everything same, then salt will be more soluble than sugar in water, right? So nature of solute and solvent is very, very important. Next term that we are going to discuss is pressure. Okay, next term that we are going to discuss is pressure. So will pressure have any effect if I increase or decrease the pressure? Will it have any effect on the solubility? Then the answer is no. In the case of solid that is present inside liquid, since solid these are incompressible, pressure will have no effect on solid, and if it is having no effect on the solute, then how it is going to affect the solubility of the solute? Solubility is only defined for the solute, and if pressure has no effect on the solute, that means it is not going to affect the solubility also. Okay, so the point for pressure will be the point for pressure will be it doesn't affect the solubility of solids in liquids as solids are incompressible. Okay, as solids are incompressible. Now the third point is about temperature. Okay, the third point is about the temperature. Now, if you have written till pressure, then it's fine. If you have not written till pressure, then it's fine. It will be not fine if you start writing now. Okay, for now, please stop writing. Okay, temperature mein, please stop writing. Don't write anything else. Just listen to whatever I'm explaining. Now, please listen. See, if I have a solid AB, okay, and I am dissolving it in water, so both of these things can happen. That I can dissolve it also, and it can also crystallize. So I will get A plus, and I will get B negative. And let us say, while I was dissolving it, I got some heat out. Okay, I got some heat out. Now, when I am getting some heat out, that means it is exothermic. Yes or no? The process of dissolution is exothermic. If you remember something from the 11th standard, that is the delta H enthalpy of dissolution, it will be negative because it is endothermic. It will be less than 0. Negative. If something is exothermic, the process is exothermic, then the enthalpy of that process is negative. Now listen very carefully. If I am to increase the temperature, then what am I increasing? I am increasing one of the products. Yes or no? Please tell me. If I am increasing the temperature, I'm increasing one of the product. And if I increase one of the product, then the reaction will go in the backward direction. Correct? Yes or no?
Yes, sir.
What about others? Alina, Dania,
Yes, sir.
Hanifa, right?
Yes,
So I'm increasing one of the products. If I increase one of the products, then the reaction will go in the backward direction. So what will happen? What is happening? Are we dissolving things or are we crystallizing things if the temperature is increasing in exothermic process? This leads to crystallization, है ना? Backward में क्या हो रहा है? Crystallization हो रहा है? Yes or no?
Yes, sir.
है ना? That means the solubility is decreasing. Solubility will decrease, है ना? Similarly, अगर उल्टा ले ले हम केस AB plus heat करना पड़ रहा है किसी चीज को dissolve करने के लिए, है ना? And then we are getting A plus and B negative. And इस केस में जब हम temperature को increase करते हैं, and I'm going to increase the temperature in this case, then I am increasing one of the reactants, and this will be favoring the dissolution, right? So if it is endothermic, then the solubility will increase. Okay. So the effect of temperature, it depends on the enthalpy of dissolution. Okay. So what I will write here, please now you can write. Okay. आप यहाँ से लिख सकते हैं enthalpy of black नहीं रहने देते इसको, enthalpy of dissolution. So enthalpy of dissolution, it can be positive, that means delta H, let us say it is greater than 0, that means delta H is positive. And the other case can be of when you have delta H that is less than 0 or negative. Delta H is less than 0, that means it is negative. Now, when the delta H is greater than 0, it is a endothermic process, right? Endothermic. When delta H is negative, that is exothermic. Now, in endothermic case, what happens? Increase in temperature. Then endothermic increase in temperature leads to increase in solubility. Similarly, in exothermic, increase in temperature leads to decrease in solubility. Is that clear? Yes or no? Please tell me. The two cases.
Yes.
What about others? Hanifa, Alia, sorry, Hanifa, Dania, Alina.
Yes, sir.
Okay. Write this down. Raise your hand when you are done. I'm waiting for Dania, Hamza, and Hanifa. Just waiting for Zad. Zad, are you done?
Yes, sir.
Okay. Fine. So we have looked at the factors that affect the solubility of solids and liquid, and nature of solute solvent, pressure, temperature. Now we are going to look at the next factors affecting solubility of gases in liquids. So here also in the first case, what we'll write? We will write the nature of gas and liquid. And so what type of gas we are using and what type of liquid we are using, that is going to define the solubility. That is going to tell me about the solubility, whether it is more soluble or less soluble, right? Now, next thing that we'll look here is temperature. Okay, next thing is temperature. So in the case of temperature, here also I will ask you to stop writing and listen to it. Okay. So let us suppose that we have a container like this, in which we have water, and we also have gas particles which are solute, and the gas particles which are solute. Now you know that what is going to happen if I start heating it. What is going to happen if I start hitting it? Tell me. Will the gas particles, they will get dissolved more or will they evaporate out? Tell me.
Will
क्या लगता है आपको
evaporate.
क्या हो, है ना? पार भाग जाएंगे सब, है ना? ऐसे भी these gas particles will be, they will be wanting to leave out, right? So what will happen? They will all leave out. That means we can say that solubility, but this is only for what? This is only for the gases. Solubility is inversely proportional to temperature, right? That means solubility decreases. Solubility decreases on increase in temperature. So from here we can also comment about the enthalpy of this dissolution, right? So we can also say that delta H of dissolution, if I mix gas inside liquid, it will be what? It will be exothermic because its increase in temperature is leading to decrease in solubility. So delta H of dissolution is negative. That is, process will be exothermic. Okay. So please write this about temperature. आगे जाओ, कोई मसला नहीं है, हम लोग रहेंगे. Yeah, is everyone done? Yes or no? Please tell me. Okay, Hamza, just waiting for you.
Sir, 1 minute. Okay, sir, done.
So now let us look at the third point in this. Please don't write with, okay, just write this third point, that is pressure. Okay, and then start listening. So I'm giving you two scenarios. Now listen. If I have gas particles like this, and where are these gas particles coming from? These gas particles, they are coming from a small inlet. Okay, so I have created a hole here, and then I am inserting the gas molecules here. Let us suppose that I added 5 more. So there will be gas particles in this phase also, right? And I have covered this thing, and I have covered this thing. Okay. Now similar is the case. I have one more case here. But the difference between this second case here is that rather than having a lid like this, I have here a piston. Okay, this piston is movable, and I have put up some weights. Okay, so weights here, this is also weight. This it does not have any weight, but in both the cases I have added 5 mole of gases. Now there is scene 1A and there is another scene B. So what do you think? Where will be? देखिए यहाँ पे आपके पास जो gas particles है ना, these are in aqueous phase, right? The solute is in aqueous phase, and here the gas particle in vapor phase. है ना। सिमिलरली यहाँ पे भी आपका सेम वेपर फेज में और यहाँ पे aqueous फेज में। तो बताइए, वेयर विल बी द गैस पार्टिकल्स मोर इन क्वांटिटी, है ना, वेयर विल बी द गैस पार्टिकल्स मोर इन क्वांटिटी, ए में या बी में? व्हाट डू यू थिंक गाइस? Where you will see more gas particles? Zed, tell me.
Sir, A.
In A? Okay, how many of you agree with A? How many of you agree with Z? Raise your hand. Z, no one is agreeing with you. The road less traveled. Alina, what do you think? A or B? कहाँ पे ज्यादा होगा solute?
B.
B. Okay. Hanifa? Hanifa? Okay. नहीं, आपकी आवाज ही नहीं आई इसी से. Can you please try again? What did you say? Yes, Hanifa?
I think B.
B. Okay. So see, let us look at the case of B here. Okay. Z, आप देखिएगा. So in case of B, can I say that this weight that I have put here, and since this is movable piston, it can apply some kind of pressure like this. The force will be acting on all the gas molecules in the downward direction. सही है बात?
Yes.
है ना? So if it is acting in the downward direction, then can you see that the chances of getting it mixed in the solution is more? Yes or no?
Yes.
But there is no such force here ना. यहाँ पे सब random है. Correct है?
Yes.
Right? So you can easily see that in the case of B, the amount of solute, it will be more in the case of B, right? So what we can see, we can say that we can say that pressure, it is solubility is directly proportional to the pressure, right? Yes or no? Solubility is directly proportional to pressure. So write a statement like this. You'll write a statement like this. First of all, solubility directly proportional to pressure. Then you will write a statement. Please write with me, okay? Write with me the solubility of a gas at a given temperature. The solubility of a gas, solubility of a gas at a given temperature is directly proportional to the pressure at which it was added. At which it was added. ठीक है, चलिए यहाँ तक लिखिए. Then we will discuss more things and we will look at the qualitative aspect of the factors, the quantitative aspect of the pressure criteria, factor that is of pressure, and how the pressure is increasing the solubility. Write this down. Let me know when you are done. The class will end now. Do you have any questions, Dania?
No, sir.
Okay, so you will have class at the same time tomorrow. Okay, but tomorrow the class will be, we have usually class of 1.5 hours. Okay, so tomorrow also you will have a class of 1.5 hours. आज आपको बस 2 घंटे का था क्योंकि पुराना कुछ पढ़ाना था आप लोगों को. ठीक है, same goes for Zaid and also Hamza. So I think आपके टाइमिंग के हिसाब से, किंगडम के टाइमिंग के हिसाब से it will be 4 PM to 6:30. नहीं सॉरी, 4 PM से लेके 5:30 ना.
Yes.
है ना, अभी तो 6 बज रहा होगा. 6 बजने वाले हैं अभी वहां पे.
Yes.
हाँ ठीक है, तो 5:30 बजे तक आपका कल होगा. 4 PM to 5:30. This will be our regular timing. Okay.
Okay.
Done. Okay. So all of you are okay with the timings, right? Yes or no? Alina, Dania, Hanifa.
Yes, sir.
Sir.
Okay.
Yes.
Thank you very much. If you have written, can I stop sharing my screen? Can I stop
Yes, sir.
sharing my screen? Yes. Just a
Okay.
minute. चलिए लिखिए आराम से लिखिए. Those who have written, they can leave. Okay. चलो bye. Thank you guys.
Okay, sir.
Take care.
Thank you.
We'll meet tomorrow. Bye bye.
Thank you.
Thank you.
Bye, sir.
Thank you, sir. Assalamu alaikum.
Walaikum assalam. Thank you.